why don't we get started? This recording and slides will be available. Of course, if you're joining us late, you can review the part you missed later. So good morning, everyone. And thanks for joining us this morning on our OMUG session focused on prop data. So we have three presentation lined up. The first one on, I should probably introduce myself for those of you who haven't met you in person yet. My name is Liming Wang. I'm a associate professor at Portland State, and with Kyle and Garth, we are the coordinator or coordinating committee for Oregon Modeling User Group, which of course is the one that organizing the current event. And for this morning, we have a three presentation lineup. The first one by Sam Granado on bringing probe data into modeling work. Of course, our second one by Chimai from Oregon Department of Transportation, focus on the RADIUS system that ODOT has set up. And finally, Josh Rowe will cover big data initiatives from both a Oregon and national perspective. And we will have a little bit of time towards the end, have you all help us brainstorming some ideas for future OMUG events. Of course, OMUG is also the body of OMSC that focus on serving the modeling community, which means all of you. So we're certainly looking forward to hear your ideas for future events. And finally, we'll conclude with some announcement for future meetings, and then we'll adjourn from there. And before we get started, I will just introduce the three speakers this morning, and then I will let them present in sequence. Of course, if you have any questions, short questions, clarifications, feel free to raise your hand or chat in the Zoom chat box. But otherwise, it's probably better to reserve the lengthened discussion after each presentation. We'll probably have some time to discuss Q&As. For each session, we have from 10 to 5 minutes, 5 to 10 minutes group Q&As. So that will probably a better time for group lengthier discussion. For speakers, Sam Granado, sorry to butcher your name.
Granado,
okay. PE, worked for MBOs directly while a city employee in Alabama and Iowa, and now supports other MPOs and the statewide model in Ohio. He has a bachelor's degree in civil engineering from the University of Illinois and a master's in urban planning from the University of Iowa. Chimai, PE, has been with the Oregon Department of Transportation for 26 years, and it's currently a transportation system analysis engineer with the Transportation Planning Analysis Unit. She leads a sub-team with work focused on data analytics and performance reporting. Josh Rowe is the active and sustainable transportation research coordinator for the Oregon Department of Transportation. While he coordinates and conducts research, Josh has experience in most elements of the analysis process, starting with data collection and wrangling, data processing, cleaning, visualization and data exploration, and finally model system development and application. Josh believes that better quantifying the cost and benefits of each of our travel options will help decision makers better prioritize investments that will mitigate the effect of inequality, reduce our carbon emission, and improve public health. With that, I will give the control to Sam for him to present on bringing probe data into modeling work.
Okay, well, first, let's see if I can get screen share to work again. So while I'm doing that, I'll just say, good morning, Oregon. And those of you who are in the modeling business, if you see something that in any of these slides that looks familiar, like you might have seen it in another presentation, since I spliced together about material from 3 or 4 different past presentations. If you see something that looks familiar, that might be because you have seen it before. But unless you've seen everything I've ever presented at conferences and webinars and such, then hopefully there'll be at least something new here for everybody. And I'm trying to see if I can get the, okay, did everyone see a change of screen just now?
Yes.
All righty, okay, yep. Yeah, what I'm going to do here, you probably saw it in the abstract in the agenda. I've broken this up into 2 parts because I'm putting travel time data really to 2 distinctly different uses for models. One of which is a straight base year validation, where I'm using average travel times by roadway segments, and then there is another part in the second half of the show here where I'll talk about how I've been making use of variability in travel times as part of estimating travel paths within modeling. And that came from a TRB paper that the model software developer and I presented at TRB 12 years ago. And probably noticed that, particularly with some of the slides I'll have later, that most of the work has been done with GPS probe data, which I think was what you all wanted to focus on. But since I've been working using travel time my entire career, including well before we had a massive deployment of this data, some of what I'm doing still goes back to floating car surveys, spot speeds, some of our permanent ATR stations that monitor speed, and that's all gone into the mix as well. And I still make some use of the floating cars, and I've got a slide about halfway down that will go into more detail on that. And then this, I guess, I'm sure a lot of you probably already know this part anyway, but the distinction is that with GPS data, that too has evolved over time. There you have a lot of, in terms of the sources of information, but in essence, it's from either vehicles or cell phones inside a vehicle that are spitting out waypoints that are both time and location stamps, sometimes at regular intervals, sometimes irregular intervals. And with the floating car, it was essentially the same idea. I mean, the user could specify, what location you wanted to write down, what time you had for at a location that was convenient for whatever your application was, which isn't always the case with GPS data, especially given depending on what kind of intervals your waypoints are coming out at, but the sheer amount of it's compensated for just by the sheer amount of data that we have available from GPS, and particularly with the connected car technology that's getting deployed out there, when you've got waypoints that are being emitted every 3 to 5 seconds. Some of our data vendors have also figured out that in addition to various other people that they're marketing this information to, they can go to the traffic engineers, the people who are looking at the performance of all the things that they're doing with traffic signal systems, and say, hey, we can give you all the metrics that you used to get from your before and after studies. So this field continues to evolve, but there's certainly more than enough for those of us in the planning and travel modeling industry to take advantage of it. And then there's always the question of why would those of us in this line of work be interested in looking at this data. And to me, I guess you can distill it down to two main things. The travel paths, there's been a lot of study over the years as to what things are more important than not, and I've always taken the position that the travel time is more important than other criteria, and I have a separate presentation that delves more into that I borrowed a 1 or 2 slides from here as well. And then particularly when it comes time to converse with our customers, the folks over in our TAC committees at the MPO or at the Public Works building, they talk in terms of the level of service metrics from the Highway Capacity Manual, and the metric that gets utilized for that is more often than not travel time and delay, including for urban streets. And those of us in the MPO world presumably are still interested in urban streets. And the other thing that I often throw in, particularly when there are modelers in the crowd that aren't necessarily familiar with the work I do, the work that I've done ever since I got started in this business has been considerably different than probably what most modelers in this country have been doing, and it just goes back to really the beginning of my career. I did not start my career in the kind of place, so a large organization, whether a MPO or a DOT, where you show up and you have a supervisor there who shows you the ropes and tells you this is how modeling is being done here, has been done for a long time, and what we expect of you. Well, when I started off in the small MPO world, there was no one there to tell me what it is I was supposed to do. Just find a way to do it, figure it out for yourself, Sam. So it began there, but what I did have instead was, again, those customers over on the TAC committee and in the Public Works building who were not shy to telling me what it was that they took seriously or what it is they don't take seriously and why. So that was how I got started, and I've pretty much just kept going ever since then over the years. And and my interest in using travel time for validation as well as traffic counts starts really from that point of view. And I thought there'd be a couple of graphics here that would help illustrate the point a little bit, particularly if you're in the modeling world, if you're still relying on things like fixed roadway capacities and volume delay curves. Well, the graphic on the lower left there that I put together from all the information and all the travel time I've attached to our statewide model, all across the state of Ohio. Well, the difference between the red dots and the magenta dots that you see over there is telling you just how far away you are from being able to get the modeled travel time right, vis-a-vis what actually happens out there on the roadway. Now that data all comes from the PM peak hour, but there's also a temporal dimension to that problem as well, which I'm showing on the lower right there. The blue line going across the day, you probably recognize as being essentially how much traffic volume there is out there by time of day, and you can spot where the AM and PM peak periods are. The average travel speed by time of day that you can see at the top of the chart, well, that actually reaches its low point or point of the highest delay during the middle of the day rather than the PM peaks, or at least that's how it works out here in the slower growth Midwest. The big cities on the East Coast and the West Coast, that can vary, but this is the pattern in Ohio, and this including the counties that are part of the MPOs that I do work for. And why is that? Well, the people who are traveling in the middle of the day tend not to use the roadway system as efficiently as the people who are out there in the peak hours. Because if you're people who are going to and from work, they make the same trip every day. They take the same route every day, and they know what they're doing, know where they're going, a little bit more than the folks in the middle of the day are. Plus, there's more trucks in the middle of the day too, and so this is the sort of thing that I also make use of as part of dynamic traffic assignment. And let's see, next is, and this is just the reassurance that, well, does all of this work? Has all of this worked out for me over the years? And if it didn't, then I wouldn't have anything really to tell you. I think the modelers in the crowd here will recognize that the black line is something that came from a long ago federal highway report on maximum desired deviation between modeled volume and daily modeled volume and daily traffic count, and I never had much problem getting underneath that curve. Now, on the other hand, when you're talking with traffic engineers and the people who conduct the traffic counts, well, as far as they're concerned, I need to be matching those numbers exactly, right? But the sampling error curve at least tells them what's realistic, and they start to understand that better in situations on projects where I've caught them trying to count the same location twice in the same year, and even with their seasonal factoring, there might still be 10 to 15% discrepancy in their count in the two counts in the same location in the same year. So then I can ask them, okay guys, which count was the real one? And then travel time error, I've divided this up into two parts, sort of the good old days, and then the next one will be the current days with GPS. Back when I relied on the floating car, how would I know when the travel time was good enough or not? And the 4 bars on the left are the MPO models that I developed, and I looked at the travel time. I decided, well, if I make use of the 95% confidence interval of the floating car surveys that I'm using, then if I manage to get the model error within the sampling error of the floating car studies, then I'll declare victory at that point. The 4 bars that you see on the right, those were the 4 times I was able to find a report done by another MPO agency out there that tried to do the same thing on their urban arterials at least, and I figure since they wrote a paper on it, they might be doing a little bit better than most agencies. But reading their papers, it looked to me like they were relying on those fixed capacities and volume delay functions that I mentioned earlier, which means you're kind of limited as to how well you can do. Or if you manage to get lucky in the base year, it may still have been more by accident than design. Okay, and here is an example of, this is the latest MPO model that I validated, and for travel times I would aggregate up to roadway inventory or a vendor roadway segment, and I'll have a couple more slides on what those look like later. And again, here's the 85-15 standard. 85% of the time I'm within the model travel time is within 15% of the observed travel time. In this case, it's actually more than 95% of the time I've been able to make that standard. Now, combining data from the various travel time sources that are out there, again, still making use of floating cars, because unlike our GPS data, we conducted that in a way that we can separate out the intersection delay from mid-block travel speed. So it's still useful for the initial coding of travel speed on model networks. Then the GPS data sources provide route by route, segment by segment, the validation at specific locations. He, I think, is going to talk more about the NPM RDS data set, so I won't mention much here other than to say that, yeah, that's what we've been able to make use of, particularly for truck speed. So whenever we have truck penalties, or more specifically the on-the-clock portion of truck travel time penalty, I've been able to make use of the performance management data for that. And then the rest of it, particularly to get an extensive amount of roadway coverage statewide, we have a contract with a vendor. Actually, our Office of Traffic, ITS, has a contract that I've been riding along for free, I suppose, with the archive data, but they get real-time data for the network that you're seeing, particularly on the right. On the left, you can see that the TMC-based roadway coverage, if you're in a urban area over 500,000 people, you get pretty good coverage there. I work a lot with the smaller MPOs that tend not to get great coverage from that system, but the vendors network that they refer to as their XD network, you can see particularly on the graphic in the lower right, a lot more centerline miles getting covered, and there are 3 metro areas you see there, one of which is over in the upper left, over 500,000 people. The other 2 are less than 500,000, and you can see in the graphic just how much of a difference that makes in roadway coverage. And now the next 2 slides I have here are really sort of a combination of what I've presented to our model user group here in Ohio, how I've been aggregating segments together, because from the XD roadway segments, sometimes the segments are a little bit too small than what we need for model networks, particularly and it can create problems with GIS conflation. Fairly large roadway segment in the model might conflate to a small XD segment, particularly if it's missing the critical intersection where most of the delay is. So I have several other slides I've reduced down to one to show how I've aggregated that, which I don't do for the freeways because the TMC network coverage tends to get it to right where modelers want it to have, you know, between all the way from one ramp to the next ramp. Now, the folks in ITS, when they want to know when stuff is happening out on the road, they would like to know where in a 3 or 4 mile segment of freeway between interchanges something is happening. But those of us in the modeling world tend not to need that much granularity. And this is just a segment of roadway, a few segments of road in my neighborhood that shows how I'm making those aggregations of segments, which I'm also using on the validation in that graphic that I showed you a couple segments earlier. And that's the material I've put together on validation, overall validation using average travel time. As far as using the variability of travel time in addition to average travel time for estimating travel paths, this was done long enough ago so that we're still at the dawn of GPS data. So there are some floating car studies still around in the development of what I put together for some of my small MPO models. It was not, some of you might be familiar with the SHARP 2 effort to build up capability on travel time reliability, particularly within the modeling community. But the work that Alan and I described in that long ago TRB paper, that was not, even though it happened at the same time as SHARP 2, it does not come from SHARP 2. This was an independent effort, but there is one thing from one of the reports that I thought would be useful to show here, that when you're working with the variability in travel time as opposed to average time, the route choice has to be constructed a little bit differently, because instead you can't just add up, I guess to use the expression from the Statistics 102 class, the standard deviation of the sum is not the same thing as the sum of the standard deviations. So there's a different way that was certainly recommended here to how to put together a travel path and the statistics that allowed them to be compared to other paths, which was called explicit route enumeration. We ended up creating a system within this particular modeling software that allows for both additive and non-additive methods to be utilized, where one involves, you can simply add up link by link the standard deviations as well as the average times if you want, and use that as a basis to compare different travel paths. But the other one is simply trying to calculate a marginal increase in the overall standard deviation. Let's see, how am I doing for time here? Looks like I probably need to speed up a little bit here. Okay, so this, again, this is material that came from the TRB paper that I can certainly share with people who aren't familiar with it, but this is pretty much the higher order math that the model software developer put together that describes what I tried to describe earlier in English. But the middle bullet here about dealing with correlation of variability across links is a critical one for runtime. Because if you tried to calculate how the travel time pattern on one link is connected or correlated with every other link in the network, then you have a model runtime that is just prohibitive. You know, we're talking about days or weeks instead of the hours that I spend doing this. So we, Alan and I, worked out a system where the correlations are only looked at, one, between adjacent links in the system, and two, only if it's part of a through movement and not correlations on crossing streets at intersections. And this is just a little bit more elaboration on the how this gets done, and the general equation that gets utilized, which came from some research that Alan found from a study in England. Again, we were pre-Sharp 2 on calculating this. So that was the general equation, and it varies by roadway classification because there are distinct differences between freeway and surface streets. Putting that together, and then this is just one of the menus as you step through setting up a travel model that lays all this out, including things like reliability ratio, which essentially says how important is variability in travel time to you, the motorist, compared to average travel time, which at least for my work, I decided to set as trial and error, depending on what the validation to traffic count seems to say it ought to be. And let's see, and so where's the data for this coming from? Again, we started with some work that was done in England, which involved an extensive amount of GPS data that already had been collected over there, both on motorways and what they call the A routes, which are like our arterials here. But one of the MPOs that I work with out here does pretty high sample floating car surveys, again, looking at the same points in time, same break points at signalized intersections, which found very, very useful to use to set up some of these relationships for urban arterials. And I even found that when I tried to just set up for myself a sample system, looking at the relationships between all these variables, the way they should be located, that ended up fitting the data that came out of their high sample travel time surveys very well, is what's shown in the highlight. And then here, what I did in the paper is just try to elaborate for a simple OD travel path between someone's home and where they work at the factory. There are, and let's say that there's 4 separate travel paths that you can take to get to the factory. The 3 different ways of estimating which path is the quote-unquote shortest path can vary depending on whether you do this the traditional way in the chart below here. You just look at the average travel time, which incorporates the intersection delay depending on the type of control you have. This slide shows it the traditional way. Then this is the additive option under model travel paths based on reliability, where you're simply summing up the standard deviations by link. And you'll notice at the bottom, these numbers were considerably higher, but not only is the comparison, but a different travel path ends up being the shortest route. And then the last option here is if you do it in a non-additive way, where you just calculate the marginal added impedance at every linkage road segment as you get to the destination. Again, you have a different estimation for every path of what the impedance is, and you have a different winner again in terms of what the travel path is. And if you've also, you may have noticed that it also means that the variability, the travel time early in the path, and means more in what path is chosen than what the travel times are later in the path. And while that was more statistical artifact than deliberate design on our part, I've always thought of it as something that made sense to weight the time and the delay early in the path as being more important than late in the path, because that's the point where you still have a lot more options available to you typically than by the time you get to late in the path, and the choices are a lot much reduced. And this is the summary table for my first MPO model validation, where I tried to take, again, the reliability ratio, which method I'm using, and which data source really was used to develop the coefficient of variation equations, and just determine trial and error which one seems to match the traffic counts and the travel time data the best. And unfortunately, it's you can try to plot those out, it's not going to be the smoothest of surfaces here. You know, whichever, for each of those three variables, you know, the best option there seems to depend a lot on what the option was chosen for the other two variables. And these things don't always work out intuitively, but trial and error options are always there. And okay, I guess that was it. I guess I figured that was as much as I could squeeze into 30 minutes. And of course, there's plenty of other material I can provide people where all of that came from, if you're more curious and want to look at more of it later on. But for now, if any of you have questions, I can take those now.
Hey, thanks, Sam. That's a information-packed presentation. So questions for Sam? So, well,
I don't know if there's a chat box. I haven't been able to notice it, but go ahead.
Right, I monitor that. There is no chat question at this point yet. So while everyone is thinking about their questions, I have one. So in your earlier slides, you're talking about the DTA, dynamic traffic assignment applications using validation. I think you in the slides you describe not application of DTA, not part of the basically 4-step or ABM model. Can you elaborate a bit on that point?
Okay, let's see if I can make it all the way back to
right here.
that. Okay, so yes, I guess that's the third bullet here. Yes, this too is something that I probably didn't come at in the same way that other modelers across the country have done, because by the time my software vendor made this option available, I was already doing a lot of 1-hour static traffic assignments for impact studies for different kinds of land uses, some of which don't reach their peak at the same time. I mean, studies for schools, you know, the peak hour there tends to be 3 in the afternoon. If there's a lot of restaurants on a particular roadway, the peak hour there might be, for volume, might be noontime. So it's not always right at 4:30 or 5 o'clock. So already doing a lot of that, and there's also a lot of situations where if you're looking at sort of a moving wave, the top of the wave as you go from traffic that starts at the downtown offices before 5 o'clock. By the time it gets to the suburbs, it might be well past 5 o'clock. So how do you deal with issues like that? That was how I switched over to dynamic traffic assignment. And it's the only thing I was doing differently from static assignment at that point is just running the assignments in sequence, hourly, 1 hour sequencing for the most part, where the travel paths, if they don't get finished by the end of the hour, then there's always the option that they might reroute depending on what the traffic congestion patterns are looking like by then. So, and I'm sure there's other things I could mention there, but that helps with the summary reporting of which locations are having experiencing their worst level of service when it's not happening at the same time of day. I also have one metro area where I do seasonal modeling, because their economy tends to be based on summer day trip tourism. If you know anything about Ohio, there's a relatively small urban area on Lake Erie that has one of the oldest large theme park, recreation parks. It's kind of like Six Flags, if you're familiar with that, except it's not a Six Flags operation. That's just, I'm using that term more generically. The name of the place is Cedar Point, but a lot of roller coasters, a lot of summer recreation, a lot of day trips. So it's not seasonal like Las Vegas or anything like that. Not that kind of recreation driven. So that's a place where, depending on where you are in town and how close you are to Lake Erie or to some of the tourist-oriented land uses, the worst level of service, the highest volume, might be summertime at 12 noon on a Saturday or 1 o'clock in the afternoon on a weekday, rather than, instead of like it is if you're doing an impact study at a K through 12 school or a high school, where that will occur during springtime and probably 3 o'clock, or any place else that's well away from the tourist locations that might peak at 5 o'clock on a weekday in the springtime. So that's the dynamic traffic assignment. Conceptually is not much different than what I did for static, but it covers all the bases more.
Great, thanks. That makes a lot of sense. Questions from the audience? Feel free to unmute yourself.
I have a quick question for Sam. Sam, in your earlier slides, you mentioned floating car method data collection. I assume you guys no longer do that, or do you still do that to supplement where you don't have probe data?
Most of the floating car data that we're still working with is circa 2000 in terms of when it was collected. And again, we're mostly using it for being able to code initial or free flow travel speeds on model networks before everything that is attributable to traffic control, curve and grade, railroad crossings, you name it. I didn't even explain a couple of slides that I had in there related to railroad crossings, which is a separate thing I'll do for TRB. But yeah, that's about the floating car. Is because we're using it for coding of networks, it serves a somewhat different function for us than the GPS data, which is mostly going for the validation side, roadway segment by roadway segment for travel time. We still occasionally will go out and do more floating car if somebody wants an answer fast enough. Say, what if we raise the speed limit on freeways throughout the state for either cars or trucks, which has been happening on occasion because of some of the issues we're dealing with statewide and with our toll road that goes all the way across the northern part of the state. So we haven't stopped doing them completely, but yes, in terms of it being a current data source for travel time, we don't use it very much anymore.
Thank you.
Okay, given the time, we will move on to our next presentation by Chi Mai. And Chi, feel free to share your screen.
Will do.
And begin with your presentation.
Can you see my screen?
Yes, we can. Thanks.
Okay. Let me see if I can set up my currently so you can see my screen, right? My PowerPoint?
Yes.
Okay, good. Good morning, everyone. I'm so glad that I'm following Sam's presentation since he set up the foundation for me. And so today I'm gonna present to you Ridis, the platform itself. I kind of try to tailor to this group. So hopefully I can hit a lot of the areas that you're interested in. I'm gonna start with some slides, and then I will do a live Ridis demo, and hopefully, you know, we can answer some questions at the end that you may have. So if you don't know what Ridis is, it stands for Regional Integrated Transportation Information System. This is a platform developed by the University of Maryland Cat Lab. And this shows you a graphic of what the Oregon subscription to Ridis entails. There's probably about 10 or more states that are subscribers to Ridis, and each state basically in our contract tells Ridis what data sources we want them to ingest, archive, and have the analytics for us. And that's the middle part here. And on the left side are the data sources that ODOT provide to the Cat Lab. And the major data source is the probe speed data, the INRIX data that we purchase so that it could be ingested. We also have a lot of the roadway detector data through our ITS program. We have incident data, we have CCTV inventory, we got national weather data, we got work zone data, and we also have the crowdsourced Waze events. And then on the other side of this graphic is, you know, we made this big investment and we want to make sure that everybody that is in Oregon that are in the transportation sector are utilizing this for their work, and so that we can make data-driven decisions. This supports real-time data. It supports system monitoring, measure operational performance, evaluate safety, mobility, and also it helps us with our investment prioritization. Who can access RIDIS? It's a very generous subscription in which everybody who works for a public agency within Oregon and Clark County, Washington can have access to it. If you have you register with a government email account, the process is pretty prompt. You get approval within an hour or two. If you are consultants and universities working on a public agency contract, you also can get access. Those actually follow like a two-step process in which they confirm back with me to make sure that this person should be given the access, and that usually gets approved within a day as well. I'm just listing at a high level some of the recent RIDIS use cases. During the pandemic, we were reporting traffic data to Oregon Health Authority. I don't know if you remember that we had the stay-home orders, and people were wondering, well, the health authority were wondering if people were complying and how does traffic look, and that along with other stats data allow them to make the decision on how long that order would stay in place. And when we were producing that report every week, we had a second use, which we were providing it to ODOT staff. And on the operations level, they were able to use that data to see that there were a lot less congestion. And so therefore, our construction office were allowed to have longer hours to work. And that really helped that sort of the economy in that sector from being disrupted. And then Region 1 produces the traffic performance report. This highlights a lot of the problem areas for them so that they can focus on improvements. We do a lot of, we use this for before and after analysis, for work zone traffic monitoring. I did this for a safety corridor traffic evaluation in which we were looking at excessive speeds. And of course, for your interest today, you can use this for traffic model calibrations. I'm listing here all the resources that we have that could help a new user get started, or even a veteran user. This is great reference. We have our RIDIS web link, which is the University of Maryland. And then we have an ODOT RIDIS website as well. We produce the RIDIS Best Practices Handbook, and I will use some of that in my live demo today. And we have quarterly user group meetings in which we highlight the recent use cases and any news or enhancement on the platform. And we also provide annual RIDIS training in the fall. We just completed that. And you can contact me anytime with questions or any requests, and I would love to help you. So right now I'm gonna jump into our live RIDIS demo. Let me try to, okay. So you can see my change to the website now?
Yes.
Yes. Okay, great. So this is the Oregon RIDIS website, which has an overview of what it is. It also has this link for you to sign up. Anybody within your you or your organization wants to sign up, There is no limit on the number of users that can sign up. Right now, I think we have roughly 330 users or register users. And again, there's no limit. We have case studies, we have training materials, and on here, like I said, we have the RITIS handbook. We have this performance matrix in which I will show you in a little bit how we use that. But these are all resources to help you as you navigate the platform. So now I'm going to jump into what RITIS looks like. It's pretty vast. And for today, I'm probably going to present to you the tip of the iceberg. This is the Probe Data Analytics Suite. This is where the majority of users end up. It has these different tools underneath them, and each produce a certain type of display or graphics to help you with your work. So the first one that I am going to do help you walk through is the trend map. So this one, and when I do this, I'm gonna help you just to kind of show you the navigation. You select your roadway. Earlier, Sam talked about XD and TMC. These are the two options for you. XD is a finer network. There's more roads within the XD network, and the segments are smaller or shorter in length. And so a lot of times I use the XD, but there are circumstances in which you don't need to use XD and you want to go with TMC, like Sam explained earlier. Roadway selection, basically, you can type in a roadway like I-405, and it'll populate up the facility for you. And you can select whether you want just the northbound direction or southbound direction. And if I want to do southbound, I can do the entire roadway, or I can do partial and just select a piece of it for my route. And so that's one way of selection. Another is to do your route selection. So this one, you can start with just a roadway here, selecting here, and then I'm going to do something interesting. I will select my second roadway as maybe up here. I'm going to exit the freeway, and my second one is here. So it'll calculate my route, and then I select that route as my, so this time it allows me to select a few routes. So then you can see the route selection here. And then you select your dates. You can select one single day, multiple days, and then you just add them on top of each other, or you can go by months, a range of months, years, and then you can deselect certain days so that you can have just weekdays or just weekends, and then you add them to your date ranges, and then you select the data, and then the granularity is the averaging of that data. And so you can, for XD, it comes in 1 minute as its fine lowest form of granularity, but you can round it up to or calculate it up to averaging to any of these other. And then you push submit. I did something already for you. I picked all of, let me go back here and do something. For this upper one, so we selected route. We can select a region as well. So within region, I can go to Oregon. and I can select, these are all the counties. So I can select a particular county, or I can select everything in Oregon, all the roadway network in Oregon, and I can select the different classes too. So if I don't want the interstate, I can pick everything else and leave out the interstate. Or in this case, what I did was I picked all of Oregon, and I didn't pick the lowest class road. Those are more of the collectors that may not end up in your model. And so what I ended up by choosing and then I chose all of 2022, just weekdays, and what the calculated result looks like is in here. This is for all of Oregon, and the display, I can display any of these performance metrics, from speed, travel time, buffer index, planning time index, all these ones. And I'm just going to show you travel time index for now. And so let's just zoom into an area. And this is at midnight. And so basically I play this, animation, and it goes from throughout the day. And I will pause at maybe 8 a.m. to see what, this is what the AM peak looks like, where you can see unreliability, congested on your system. And then you can go to the PM peak, the midday, and then run through to the PM peak and see the results. So this is for 5 p.m. and you can see that it's the worst time in the day. With any of these, you can change how you want the display. If you don't, for this one, you can jump to another tool without having to do the query over. You just pick this and then jump to another tool. Then you can save this animation. This data can be saved in an Excel format, or it could be in any of these animated format, so that you can send it to someone and have them, sometimes you can embed it onto a website or a newsletter if you like. So that is the trend map. This is the congested scan I want to show you. It's I did a selection of let's see, of Sunset Highway eastbound, and this is so if you're doing a calibration for a particular route, you can you can look at where your congestion is located. This on top is the time of day, and then this is the distance along that corridor. Starting on the bottom is Chute and Helvetia interchange, going up to 217, and then heading into downtown Portland. The zoo area, and tunnel is right here, which is where the most congestion takes place, and you can see it's most of the day. And so from a modeling standpoint, you can use this to calibrate your model. And this is another one that you can jump into another graphic and display and be able to, so this one might take a little while to jump into. So I'm gonna move on to the next one and we'll come back. But basically it jumped into this other chart, and what you were seeing is speed, but we can, these other charts will allow you to see it in travel time, which and other performance measures, which is what Sam was talking about earlier, wanting to calibrate a certain route with travel time. Another thing I want to show you is going back to this is called the congestion causes of congestion graphs. And here is also starting with the tool. And this one, I don't have some of these tools only allows you to use a certain data source. So this one was only developed for the TMC in-rig segments. And then you can pick whichever region you want, or you can pick a roadway. And with this one, I picked Oregon. I believe I started by picking Marion County. And then I picked all of 2022. And then I picked that. I added my the cost for vehicles and passenger vehicles in terms of delay, and then for trucks, these are the numbers that ODOT developed. And I pressed submit, and what resulted was this causes of congestion graphs that tells me for Marion County 2022. I excluded interstates because I wanted to know what the I didn't want the interstates to overwhelm the congestion that's on the local system. A lot of times in Portland, when you pull that data, there's so much congestion on the freeways that it's harder to know what's happening on the local system. So I purposely, for this one, excluded interstates. And so for 2022, for the arterials that are in and collectors that are on the local in that county, and also it has state routes as well. 29% of your congestion are attributed to just the presence of a signal. People come and they are delayed at a signal device. And then we have recurring congestion is 16%. So this is your daily congestion that are recurring on a daily basis. And then note that weather is 6%. And then for holiday, it's about 3.7%. And so that's for Marion County. And so, and then we have these multiple causes are the pie chart are when there's multiple events happening together. So they are grouped into that. But by looking at Marion County, I looked at Deschutes County, developed the same thing. Their signal delays are attributed to signals are around 29%. So not that big of a difference from Marion County, but I saw that holiday congestion basically is higher. It's at 7%, and that makes sense because this is a recreational area. People love to have vacation homes in Bend, and they love to go there for major holidays to recreate. So it does make sense that doing the travel to and from the holidays that we do see that they experience more of that as a cause. And then this one is for Umatilla County, and this is an area that we were asked to pay attention to because they don't have a lot of roadway connections there. So when there's a winter event or weather event or any kind of natural effect on their system, they don't have alternative routes. So a lot of times they close down the highway and everybody is stuck. And so you can see that they really, for 17% of their congestion is allocated to weather. That's a big value compared to the other ones that you've seen earlier. And then I'm just gonna go to the last one that I pulled. This is this is the metro area, which has the Clackamas, Multnomah County, and Washington counties. Again, we have these different break out of the pie chart allocated to different causes. And at this point, I'm going to try to go back to here and see. So this is that conversion of the congestion scan on I-405 to a more of a graphic form. And again, this, I can pick anything. This is speed, and I can go and I'm going to see if I can change this to travel time if I want to calibrate. And sometimes this is showing the little color shading is the 95th percentile and 75th percentile. I can remove those if I wanted to and just look at the average. And so this is an example of you can look by time of the day when your travel time goes up and where your system is having issues. And so this is in the AM peak, and you can see that for this particular route, Sunset Highway eastbound, that PM is the worst of the two, and you can see the extent of it. 7 PM is when things are starting to get back to perhaps free flowing. And with any of these, again, you can export the either the image or the Excel to do further embedding into other documents. So at this time, I'm going to pause and show you the handbook, because I think that's important for you to, it's a great guidance to help us to, even myself, I developed the handbook, but I still go into it on a weekly basis as I navigate the tools to look up information. You go, if you want to, we don't want data to be a black box here, so we have a section that talks about data, what's all embedded in or ingested into RIDIS, and so that you can make your selection appropriately. You can read up on what the difference is between TMC and XD, and so that you can understand and use it appropriately. And so I think, and then each one of these get you back here. You can go into this one that basically is the start of each of the tool that can get you into the how to navigate through the tool. And the next one that I'm going to show you is this one. It's so the tool is very robust, but sometimes you just want to download the data and do your own analysis. Maybe there's you don't agree with the calculation or the methodology that RIDIS platform has, because their platform is developed for all the states that are subscribers. Nothing is customized to us other than the data that we ingest. So let's just say you just don't agree with how they calculate a certain reliability metric, and you want to do your own. You can go in here and choose the data sources. You can choose, just like what I did, choose any type of facility or area that includes a group of facilities. You pick your date range, and down here you pick all the specifics, and you might come down here and you might say, okay, this is all the things that you're that you can produce in your download. And I don't understand what historic speed is from reference speed, or what C value is, or confidence score is. Well, that's where our document comes in, is that each of these will walk you through step by step of what selection you would want. And we have recommendations where we know that maybe new users are debating what to pick. So we have recommendations to guide you through it. And we explain to you what the different, you know, for this selection, the no recording handling checkbox lets you exclude records with no data. This can help decrease the size of the export. Users should leave this box unchecked. So that's an example of how this document can help you navigate the tool. And again, it explains to you all the different data that you can that you would have question on. So with that, I'm going to go back to this, and I made my selection. I picked my I-405 as my roadway. I made my selection. I go through the whole process, and I push the button, and what I come up with is these two spreadsheets. The first one is basically the XD ID. So these are the segment IDs. And this one is, I selected every minute of data by my granularity is minute. So then every minute it tells me what the speed is for that day. And then the average speed, which is for that typical type of day and time of the day, is about 55. Reference speed is the free flow speed. And then your travel time in seconds, the confidence score, and the C value. These are basically, if there's an explanation for both of these. But if there's enough data, then these are in the higher value, so that I think this one is the when the data is enough to of real data, so that there's not supplemental historic data that would make up this number. And then the C value is whether this one represents sort of I think it represents the average, or if this is way off, then there's some anomaly with the data that we need to be aware of. So these are two very important values to understand if you're working with the raw data. And then the other file that comes out when you download the data is this basically almost like a metadata that tells you for this particular segment, how long the segment is, everything about it, the lat long for the beginning and end points. So that's what you would get if you were to download the data. I see that I am at the end of my presentation, so I'm going to stop now. And oh, if you will allow me, I just want to show you one more document that's really important for you. So this is a spreadsheet, and also you find this on our website, that lists all the tools that that we have in the what we call the probe data analytics toolbox. I've only shown you a couple of them today, but if I'm looking for certain performance measures that I want to be as an output, let's say I'm interested in travel time, then I go to here and I know that there are four tools that allow me to retrieve travel time. So then I come back to here and I go back to, on the left side is all the data that support that tool. So some of them have both INRIX XD and TMC, and some of them don't. This one only has TMC, so I know that if I'm only interested in XD, then this would not be the tool that I would choose. I would choose something like this or any of the other ones that fits my criteria. So wanted to demonstrate that as a valuable resource for you. So at this time, I'm going to stop sharing and see if there are any questions.
Thank you, Chi. That's great presentation, and at least very helpful. I have not used Redis myself, but also I know a student, at least a student, I believe Curie she's in the presentation. You appreciate your assistant helping her getting access to the Redis data for her dissertation research. So great. Sam chimed in and shared his experience also, I believe, with Redis in terms of kind of download when you do analysis, select a fewer road classes, so the file size will not be kind of overwhelming. And another point is, oh, maybe if, or you can chime in, Sam.
Is for Sam, is that a question or is that, I'm trying to read, let's see.
Not a question, but kind of share some tips.
Yes.
Yeah. Another tip is you can also download the shapefile for the XD network separately. So yeah. So kind of for the metadata, not only you can just get those lat long, but also the shapefile for the network.
Yes, and thank you, Sam. I forgot to mention that we do have a location where we keep the shapefiles that we point our users to that, because some of our users want to work with the shapefiles and the metadata and the downloaded data and do their own calculation, and that's really helpful. I know that Josh does that quite a bit. And then I think the first comment was about file size. Is that right? I can't see. Let's see. It's also from Sam.
Right. A question of mine. So far, there is no question in the chat. So for the audience, only feel free feel free to unmute yourself and or raise your hand if you have any question. Question of mine is, how much do you know in terms of the basically reliability or development? Do we have any idea in terms of the validation or validity of the speed, congestion, and to whatever extent that you have any idea in terms of the validation in those data from Redis system?
You know, we haven't done that. For the last couple of years, it's been getting the contract in place, getting it up and running, and then using it to, you know, promoting it to our users. But it is on our to-do list is to continue to work through some of these tools to two things. One is to pull some sample data and do some validation. The only thing is that we don't have the, like we'd have to do floating cars or something, or we have to, I think we can probably pull some ITS data that are Bluetooth collected and do some of that. I know initially we did just a small sample and it looked good. But now I think it's something that we need to continue and do a more robust job at doing that. And then the second thing we want to do is pull some of these calculations and do our own calculations and compare our calculation using their methodology with their results, just to kind of, you know, I think it's just good practice to do that. And so that's on our list of to-dos.
Question from Carol in the chat, approximately how many agencies are currently using the Oregon Artist system, and are there many users at local agencies, for example, city and county level?
We currently have, like I mentioned, about 330 registered users. We find that we get a lot of users from ODOT, of course, and then we do have I think the next highest level of users are our local agencies. And I don't have the specific numbers, but we've been doing a lot of promotion of bringing RITIS out to people so that they know it's available to them and they have access to, that they can access it for their work, because this is a very generous opportunity that everybody within Oregon, all the local agency can do it. I know that even WashDOT doesn't have, they're not subscribers to RITIS yet. And so the fact that this is available, I think people should really take advantage of that. The sector of groups that are not high users of RITIS, in which I would like to change, are the consultants. And I find that you know, they're going to be working on government contracts. And so that's the sector that I really like to get more, you know, engagement with and get them really proficient at this tool.
So you mentioned the consultant will be able to get access to through if they have a current work with a public agent.
Yes. Okay. If they have a contract, they get access. Yes.
Okay, great. Thanks. Okay, thanks, Chi. I don't see any more questions. Certainly appreciate your effort to produce the resources, guidance, and an assistant for pretty much everyone, including the student at PSU, to help utilize the great resource. So for the interest of time, let's move on to Josh to give it a bit, talk a bit about the big data initiatives, both here in Oregon as well as the nationwide. So, Josh.
Great. Thank you, Professor. You hear me okay?
Yes.
Great. So, yeah, I am looking to share a bit of information with the group, and ideally, this will be kind of two-way because I'm looking for some feedback on the three elements that I'm going to walk through today. In terms of the, you know, real big picture, the lay of the land of everything that's going on, that's not what I'm going to cover today. I'm going to try to be a little comprehensive about what we know is out there for vendors or whatnot. I'm looking for some input there, but these are just a couple key items that I'm associated with, that I'm aware of, that I want to share out. And like I said, I'm looking for, especially from folks that I don't interact with a lot, a bit of input on a couple of things. So I'm going to talk through a little of the work that we've been doing over the last year through the TRB Committee on Highway Travel Monitoring. This is real like base year focus, so not modeling. That's the purview of that committee. We'll walk through a little of what the e-circular was, and then landing on some of the big data related research ideas that are coming out of that. Want to walk through and show to this group who's probably seen it before the third-party data provider matrix, and get some input there. And then I'm going to end on some work that the unit here at ODOT that I work with, the research unit, is finishing up, and talk a little bit about how that does connect with the goal of monitoring pedestrians, and then also connecting with big data through the kind of traditional way that we're thinking with like probe sources and whatnot. So the Highway Travel Monitoring Committee at TRB, I led an effort this year that's finishing up. We're putting the final touches on an e-circular that will be 11 chapters long. Each chapter focuses on a different element of highway travel monitoring. Short duration counts, travel times is in there. Thanks, Sam, for your help with that chapter. There's some stuff in there about probe data, bike ped, and e-scooters or micromobility has its own chapter as opposed to a standalone e-circular this year, which I think highlights the increasing seriousness at which those modes are being taken in the transportation realm generally. And the idea with these this particular e-circular is just to lay out the state of the practice, state of the art, and some of the emerging trends within each of these chapters to help set a course for the committee to in terms of a research agenda for the next 5 years. And so the piece that I'd like to share out with this group and get a little feedback is around the research concepts that came from the probe data for volume estimation chapter, where we as a chapter group came up with these 3 research ideas. And the first one, there's been evaluations of these third-party data products like Streetlight and INRIX. We've done a couple in-house. There's a really great pooled fund that evaluated Streetlight data. But those products are already changing. They're almost changing every year. And so now it's this research concept, the first one, understanding data quality across geographies, populations, time, and data, changing data inputs, is about like doing a little bit more of that, understanding how error and other data quality measures change across time, different disaggregate temporal spans across years, to basically provide information for folks who are looking to purchase these types of products around what they can expect for data quality. The other research concept is related to creation of like a third-party data evaluation clearinghouse. So the idea here is that you would have kind of a one-stop shop to know for a various data product if evaluations have been done and what those data evaluations, those data quality evaluations have shown. This is a little bit like if folks who do safety analysis are familiar with the crash modification factor data clearinghouse that Federal Highways runs. And this is like a compilation of all the studies about lane widths and like what that does for safety performance. And that they have a rating system within that for each of the studies. So you can kind of go in there and quickly search like for a given roadway or intersection treatment, like what is the quality of evidence for crash reduction potential. And so the idea would be similar, that we would have something like that for these data quality assessments for third-party data products. And then the last one is around looking into the technical and fiscal feasibility of developing some of these big data fusion models of our own. We actually have a research proposal going through the ODOT research cycle right now that's very similar to this. And the concept here is just generally like these third-party providers, we can purchase their products. There's a lot of challenges. We have to go through those earlier kind of proposals that I mentioned here of like evaluating them, but then things change. We don't really know how. I know we've dealt with this with the speed data to a certain extent. And so the concept here is like, is it feasible for state DOTs or a consortium of state DOTs and other transportation authorities to build one of these themselves? And is that a good, is that fiscally reasonable compared to like what the cost is of these products off the shelf? And like, what does that look like, especially in state DOT budget situation that is increasingly constrained? But I'm curious for the group here, like what kinds of questions that you've had generally, maybe they don't fit into something that's like a research idea that would go into the e-circular, but what are some of the ideas around or questions you've had around probe data for volume estimations, not so much that travel time question, I think that's separate, but for travel monitoring, and maybe not necessarily in the forecasting realm, but for sort of understanding the base year conditions that you've all faced. And I would be interested to know that, because I think it's helpful for this TRB committee to kind of be aware of some of that. So maybe put some of those questions in the chat, and that way they're sort of documented, and we can even maybe at the end here go through a couple of them. So moving on, let's see. So one of the other things that we've been trying to keep a handle on are the sort of like environment of these third-party data products. This third-party data transportation data matrix was first created by Joe Broach and some others I've been trying to keep it up to date for the Organ Modeling Steering Committee effort that I'm sort of assigned. And I hope folks can read this okay. What I'm looking for here is two things, just to sort of like, for folks who aren't as familiar, like, there's a pretty big ecosystem of these providers out there, and it makes it hard, in my opinion, as a transportation authority, to keep on top of them all. What data they use, what are their methods, what capabilities do they have, and functionality. Because it seems like I'm getting, you get emails and you're seeing things in the news all the time, talking about these types of products. And so we're trying to have a, some basic level of summary about them. And so I would ask the folks attending today to take a look at this. And if there was some on here that I'm missing, let me know, because it's been increasingly difficult to stay on top of the landscape for these products. And so similarly, putting that in the chat would be really helpful. Let's see. And then the last thing I wanted to make this group aware of is some work that we're finishing. The research team at Portland State and Utah State University are finishing up. Sarisha Katuri at Portland State and Patrick Singleton at Utah State were the PIs on this project, where they looked at the relationship between the push buttons collected from our traffic signals and the relationship with actual pedestrian counts. And there was some work previously done at for Utah DOT that found like there's some pretty good relationships here, and with some pretty simplistic factor development, you can turn those push buttons into actual counts, or something pretty close to counts. And so we had them repeat that work, and it was pretty good. It was, in fact, very similar to the Utah models that were developed when they compared these two data sets. And whoops, we even actually applied the Utah models to Oregon data, and the Oregon models to the Utah data, and there's very similar outcomes, suggesting that there's pretty good temporal stability about these models, and even spatial transferability. And so we're moving forward with some data integration and some data use. And the reason I think this is big data related is because the signals data is in fact very big, and the state data center has been unhappy with ODOT and the amount of data that we are trying to stuff from our signals into some of the databases that they manage for us. So we've had to come up with some aggregation things to get around that. But the thing I see that's even more important to connecting to big data is the way that we'll ultimately use these types of data, which essentially, once we factor the push buttons, turn into quasi permanent counters, which just in terms of sheer numbers, ODOT manages about 800 signals that collect the push buttons. And we're talking with partners in the Portland metro region about getting their data, City of Portland, Washington County, and should have almost double that count of 800 just in the Portland metro region, not to mention the other local agencies around the state that, if they had interest, could contribute data. So we'd have a significant number of these infrastructures, providing data, and them on their own would give us some information about volumes for PEDs at the intersections. But ideally, we could merge those with other sources from either Strava or streetlight data or other third-party providers to then allow for estimating out volume estimates across the network or at places on arterials at the very least. And so that's a little of the connection I see. I have a link here that I can share that is summarizing what we have for ODOT data with these models applied for the ODOT signals, and a really cool data visualization that Sean Strasser built. Sean Strasser is a signals staff person here at ODOT and done some cool work with integrating some of this research. We're hoping that there's a path forward to getting these data put into something like PSU's bike ped portal. And so we're kind of working through what the details would look like for that. That would allow us to integrate other agencies' data and maybe provide a couple different ways of visualizing and providing access to these types of data. So that's kind of the three bits that I wanted to walk through today. I'm curious if folks have ideas for research that we should be thinking about on the national or local, here in Oregon level. What kind of data products we should be including in that list of third-party data providers. And then if you have any questions about the push button related research. And I'll put these resources in the chat just so you can start poking at some of the bits here that I'm trying to share. Sarisha did a really great presentation at Portland State University's Friday seminar on the push button work. So if you want to follow up with that, there's a lot of good information there.
Right. Good point. I don't have the link right now. Can probably add to the to OMUG page for this presentation. So there is a couple of comments, questions from the audience. Sylvian point out flowlabs.ai. Yeah, that's
great.
something I am not aware of myself either. So.
Oh, yeah. Okay, yeah, I'll definitely add that if it looks like it's like within what we're tracking here. It does look, and what a fun name.
This is Sylvan Hoover. That was one that actually Sean Strasser mentioned to me. So, and he might have more familiarity about it, but it looked like they were trying to get into GHG and sort of other modeling space.
Great, thanks, Sylvan. I guess that's my time, but yeah, I'm interested with this group and the OMSC group about what is our course forward with some of these products. I think I don't know how much discussion folks are having in their agencies or at their their firms about these products, but I feel like we should be trying to wrap our arms around it a little bit more and trying to understand things a little bit more. But maybe I'm missing out on some of those conversations that are happening anyhow. But I appreciate the time today with this group, and happy to chat offline too if folks have interest.
Yeah. Okay. Thanks.
If
yeah.
Nothing else has anything to add for Josh's, I guess the least I could do is thank him for the shout out that he gave me earlier on the e-circular, although actually it's Xu Zhang who should be taking the credit for that one, with all the work that I believe he's done with you on the e-circular. My role is more as the co-chair of the subcommittee to encourage people to do as much as they can. But Zhu works with Mei, who is also the co-chair and is well aware of the work that we're trying to do. And yes, this is a long-term thing. We are even now still working on funded NCHRP projects that came out of that last e-circular 5 years ago. And I have been, and since Josh and I are both going to be at the committee meeting next month, where we're going to be talking about this some more, I've already been encouraging my friends list for my subcommittee to either participate on site, as Josh and I will, or even virtually, since Yanni makes that option available for people who even can't get to Washington. So please, if you all have ideas to propose, let Josh know about it. I've even, as far as getting volumes out of probe data, I mentioned a little bit earlier, I have a MPO that needs a lot of seasonal modeling, and I've been putting Streetlight to use, coming up with volumes by season where it's hard to find enough hoses to throw out even once during the year, every place in town, let alone 4 or 5 times a year. But we do constrain all that to what we're finding in our host counts, because I'm sure Josh knows at least as well as I do how cautiously federal highway staff wants to move on embracing probe data for volume estimates. So again, thank you, Josh, and just wanted to make sure the other people who actually are doing the work are getting credit as well.
Thanks for that, Tim.
Yeah, thank you. So if you have any ideas or research ideas in terms of big data, certainly reach out to Josh. And I want to thank all three of you for a great and very informative presentation. And with that, I will probably switch gear a bit to gauge your all input in terms of the idea for future OMUG events. Are there any interesting recent model applications in your agency, or something you are aware of, either locally or in Oregon or even elsewhere? Or are there any emerging topic of interest, again, to either yourself, your agent, or in general? Beyond the few that we, or at least one, and where that we were organizing for the post-TRB social networking events that likely will happen in late January, early February. Are there any other kind of networking opportunities that you're aware of, like to share with the group or with the larger OMUG community, or if you have any thoughts in terms of how, in terms of events, in terms of how we can kind of further engage the community and so on. Any thought, feel free to share those. So we do have a few in the docket. I believe it's next slides, but yeah, but we certainly beyond those, any ideas, any suggestions for future events?
Li-Ming, I see that we have mostly agency folks on the line, but maybe we could also ask everyone to check in with consultants that they're working with. Maybe there are consultants that would appreciate the opportunity to get work that they're doing in other parts of the country in front of the group too.
Yeah, that's a good point. Yeah, if you are currently working with a consultant that they are wrapping up their work for you, for your agency, or elsewhere that you would like to learn a bit more, I generally do think kind of organize or more or less force them to kind of package the content in a half an hour, 45 minutes format. Sometimes help kind of help convey the whole idea. So that might be a possibility, idea. We're certainly looking forward to hear from you. In terms of what we have for the upcoming OMUG event, we will schedule the post-TRB brown bag. So if you are going to TRB, or anyone that's going to TRB, and volunteer or willing to share your takeaways from the TRB conference, certainly feel free to reach out to any one of us for the committee, for the OMUG coordinating committee, and or directly to me. I believe I will be the one that more or less so-called host or moderating that brown bag. So looking for a email announcement, probably is pretty soon, I think. So, Josh, there's few chat there. Okay, that's about the matrix there. We do have some idea to host a OMUG session on and related to today's topic there as well. It's the speed volume analysis that Shen Chu from ODA did some exploration on the, I believe, based on Redis data, and we will of course we'll probably add a few more presentations related to that topic there. And if you have any work related to that topic, if you suddenly reach out to us or aware of somebody else has done, of course, we could potentially, Sam, tap you again. That's a possibility. We do have, Josh already mentioned the work, the kind of wrapping up at both PSU and USU, and we will probably do a session on pedestrian actuator data for modeling applications. Josh, Alex, potentially tap Shirisha on that topic as well. So I believe we also talking about having a vision eval session sometime in the future. We haven't pinned down the rough date yet, so that is something that we will do. What else? I think that's all we have at this point. Dan,
I kind of flew by that slide here, and maybe just give the group another minute and if there's any suggestions before we adjourn the meeting. No one has ideas today. So, but we will convene the three of you, the coordinating committee there, pretty soon and see if we can shout an event schedule for the next year or so.
Yeah, let's do that. And finally, I think let's go back to the final slides. A few upcoming conferences that, of course, that we are aware of. There's probably certainly not a complete list, but might be of interest to you. So TRB, of course, we do have a scenario planning conference organized by Lincoln. I believe Lincoln Land Institute consortium for scenario planning that actually here local at Portland from January 31st to February 2nd. And OSU's Northwest Transportation Conference, that's in March 4th to 6th. And then April AMBO Planning Tools and Training Symposium. It's from May 6th to 9th in New Mexico. Feel free to share any announcements or conference events that you're aware of that may be of interest to the OMUG members. Okay, see now, so yeah, that will conclude today's session. We will thank you all for participating, and particularly the 3 presenters. And we will have a record video that's available on our website, and I believe the slides and a few notes link to the matrix, including Josh's matrix and potentially Chi's user guide for the Redis will be available there. Okay, with that, thank you all. I hope to see you in one of the future events of OMUG.